Hello, and welcome to the Gaming with Science podcast, where we talk about the science behind some of your favorite games.
Today, we'll be talking about The Search for Planet X by Foxtrot Games. All right, everyone, welcome back to Gaming with Science. This is Jason.
This is Brian.
And I'm Addie Dove.
All right, we have the inestimable, incorrigible Addie Dove, who told us just before recording that she comes from the best podcast, Walkabout the Galaxy.
I have the shirt on today, too.
Oh, cool.
Which, sorry, listeners, we can't show you that it's an audio podcast, but you can look it up. I'm sure they have it for sale somewhere. Anyway, Addie, can you introduce yourself to our audience? Let them know who you are and why you're on the show about finding Planet X.
Happy to, yeah. Hi, I'm Addie Dove. I'm a planetary scientist and physicist at the University of Central Florida. So my day job is that I do research understanding planetary surfaces. I study dust in space. So dust specifically on the moon and asteroids and how it behaves and how we understand it. I'm involved in a number of experimental projects and missions. And my favorite part about my research is that I've done things on orbital assets, so on the ISS, on CubeSats, and on the Vomit Comet. So I've actually flown on the parabolic airplane flights.
Fun, or well, I don't know. I've heard about the Vomit Comet, maybe not so fun, but it's fun to have
It's awesome.
done.
I love it so much.
So you are an astroquark. That's what the hosts of the Walkabout the Galaxy podcast call themselves, yes?
It is, yes.
Are you bottom quark or charm
I'm
quark?
charm.
You are charm quark.
I was
Jason was
right.
right. He
Yes.
was right.
Yeah, so we have strange and charm, and then we also have bottom, and lately our newest astroquark is down. So this is a clever name that we have because we're mostly astronomy folks, and it's an astronomy podcast. And quarks are sort of like the fundamental units, right, of matter. And so there's strange, charm, top, bottom, or truth and beauty, if you like those names a little bit better instead
Ooh.
of top and bottom, and then up and down.
Truth and beauty are substitutes for which ones then?
Top and bottom.
Yeah, same initials, but more poetic
Yep.
names.
Okay.
One of our quarks enjoys being beauty, not bottom. So
Are you allowed to have more than 6 hosts then? Do you just have to nominate people on and kick people off?
we've had 2 tops technically. So as we've had people iterate through.
Well, you can get someone to be the glue on holding them together.
Yeah, exactly. And some quarks have lasted longer than others. So we've had a couple of replacements, but
All right. Well, I think that's already given us one fun science fact is the quarks in matter, but let's go on.
I guess it is.
We like to start with some fun science fact. And Addie, as our guest, you get priority. Is there something fun about science that you've learned or run across lately you want to share?
oh man, let me go second. I have to think about it a little bit more.
Okay, then I will go first, but I think this is probably something you already know. So if you want to hop in, that's fine. So my challenge is always, how can I make this about onions in some weird way? So what does the moon smell like? I learned what the moon smells like from the people who have been there. And I know, Addie, you definitely know this. For the people who have been to the moon, lunar regolith smells like spent gunpowder, evidently. Although
Yeah.
it doesn't last, because when those samples were brought back to Earth, it's now odorless. So there's been some speculation about why it's like that. Now, I have another question for you, Addie. Again, you probably already know the answer, so I'm going to make Jason guess. We're going to do a stump question like you guys do.
A stumper. I love it.
What astronomical body smells like a combination of cat urine, burnt matches, and rotten eggs?
Okay, cat urine, burnt matches, and rotten eggs. So cat urine is going to be like ammonia compounds, probably in urea. Burnt matches is phosphorus, and rotten eggs is sulfur. So we got ammonia, phosphorus, and sulfur. I'm going to guess Io, Jupiter's volcanic moon.
Comets stink like that, according to the organic molecules. So
Oh.
we've found organic molecules in lots of astronomical bodies, in asteroids, in dust. Yes, in planets, of course, but the missions that went to the asteroids picked up glycine, which is an amino acid. They also picked up hydrogen sulfide, which is one of the flavor components of onions. So if you were to have a human mission to an asteroid and go inside, it would smell really, really bad.
Oh, yeah. I was trying to think, is it Titan? Is it Venus? Interesting. Okay.
I mean, I guess you're protected by the spacesuit until you bring the samples inside with you, and then you've just contaminated your entire spaceship with rotten onion smell.
And cat urine.
And cat urine. Which, like future spaceships, maybe are going to smell like anyway. I don't know.
All
We
right.
can hope in some ways.
So that was my science fact. Comets smell bad.
I like it.
How about you, Addie? You come up with one?
Yeah, I was trying to think. There's been a bunch of interesting JWST results out lately. So the James Webb Space Telescope. So I feel like a lot of my sort of like new science things are from that, but I don't know if they're facts. They're like new things we're seeing that are sort of like blowing our mind, right?
Can I pitch something you guys were so excited about on your own podcast that you could
Yes,
talk about here?
sure.
So there was that asteroid that we thought would hit the Earth, and
Oh.
now it's going to hit the moon, or at least there's a better chance it's going to hit the moon, right?
Yeah, so there's an asteroid that's great. Yes, I love talking about YR4. So there's this asteroid YR4, 2024 YR4, which has to do with like when it was discovered and what discovered it. And it's this like asteroid that has a very elliptical orbit. So it came near the Earth back in 2024, and it's going to come back in 2028 and 2032 based on its orbit. We hadn't seen it before, and then we discovered it, and the predictions were that when it comes by in 2032, it was going to hit the Earth, and it was a 3% chance that it was going to hit the Earth, which is actually a staggeringly high percentage chance for asteroid encounters. That's the highest we've had in a really long time. But then we looked at it with more telescopes and got more data about it, and it's not going to hit the Earth, which is great in a lot of ways, but also kind of disappointing
Oh,
because it's
you
probably hit
sound
the
so
ocean. We get to
disappointed.
study so much. Yeah,
How
I mean,
how
like,
big is this asteroid?
it's pretty small. So like it would be something that like if it hit in a city, it would be really bad news. But like statistically speaking, it would hit in the ocean and we'd be able to like observe it coming in and see it disintegrating and see the big splash. And it's not like a dinosaur killer asteroid. It was more of like a Tunguska event kind of thing where it wipes out a big area, which is this old location that it hit. It was an old meteor that actually like sort of disintegrated in the atmosphere. And so it created a shock burst and leveled trees for miles, but didn't destroy anything. So probably something more like that. So we don't think it's going to hit the Earth, but there's a small chance now that it might hit the moon, which is kind of exciting.
That I agree is going to be cool because if we can see that and not be in any danger from it, that sounds great.
Exactly, right? Yeah.
Yeah, you guys were all bubbling with excitement about the idea that it might hit the moon and what it would mean for study. Like knowing it was going to happen, being able to point every telescope at the moon when this happened.
Yeah. For so long, and we'd see the impact and we'd learn a lot about it and the moon. Ah, so much data.
All right. Well, let's segue on to this game, which also actually involves asteroids, not impactors, just trying to find them and point a bunch of telescopes at them. So, game for today is the search for Planet X. So, quick background, this is by Foxtrot Games and Renegade Game Studios. I assume Foxtrot is like the creator of it and Renegade is more the distributor of it. It's actually very highly rated. It's 107 on Board Game Geek overall. So, 107 out of all the games there, which is actually really, really high. Basic stats, plays for 1 to 4 players. Again, the obligatory single player mode. About an hour runtime, ages 13 plus, which, as we now know, means that they didn't test the pieces for safety for eating. So do not eat the pieces of this game. We don't know what will happen.
Yeah, something bad.
Retail price is $45 currently on Renegade's site. And what does this game consist of? So this is a deduction game, which for having 2 of these in the past 3 episodes, I didn't know about this genre as a genre until earlier this year. So when we're choosing these games, we don't choose them based off of the type of game. We choose them based off of the science and the field of science we're talking about. And so this is complete coincidence. We've had 2 out of the last 3 being the same genre. But the idea is similar to Turing Machine. You are trying to find something out. In this case, it is the location of Planet X, which is this mysterious 10th planet in the solar system, maybe 9th now due to Pluto getting demoted. You're trying to find it, and you're trying to figure out other things like asteroids and comets and gas clouds and their relationships to each other. So the board is this large circular board that if you're playing normal mode, it has 12 sectors. If you're playing advanced mode, it has 18 sectors. And each sector has something in it. That something can be Planet X, or it could be asteroids or comets or gas clouds or dwarf planet or nothing. Some of them are just empty. And the thing is, there are logic rules that control where certain things show up. So comets can only show up in sectors that are prime numbered. Dwarf planets can't be next to a gas cloud or something like that. I don't remember what all the logic rules are, but they have logic rules that connect where certain things are in relationship to each other. And your job, you have these cute little telescope-shaped meeples, which are actually based off of 4 real telescopes in the world that represent your players, and you're going around this circular track that represents time. And so the idea is that as you you go around the track, you're doing one of several things. You are usually surveying the sky, looking for a certain type of object, or you are doing a target analysis where you get a lot of data on one specific sector, or you're doing research, which doesn't tell you anything about the sky, but gives you some more logic rules that help you kind of figure out the relationships among individuals, or you're trying to figure out, you say where planet X is. And importantly, to win, you have to know not only where planet X is, but you also need to know its neighbors to the right and to the left. So you can't just guess randomly and hope to have it. The odds of that are just too small. And if you guess wrong, there's actually a significant time penalty in terms of moving your piece ahead. And so guessing is bad. Like guessing generally is a bad thing. Other various components of the game, there are little player screens that tell you all the logic rules. They actually have a clever little card insert that will replace the basic rules with the advanced rules if you're playing the advanced version. It has the highest quality score pads I've ever seen. They're all in full color. There are 4 different ones for which side of the board you're sitting on, and they're front and back for basic and expert mode. So like these are high quality stuff. Like I've never seen so much effort put into a score pad before. I was impressed.
They looked nice.
And then the one other thing in the box, which I was not expecting, is actually an advertisement for the Planetary Society, which is a nonprofit organization that funds space research. And I thought that was cool. I actually used to be part of the Planetary Society. I think I let my membership lapse a few years ago. Sorry, Bill and I need to start that up again. But I thought that was cool. The Planetary Society is doing a lot of good public science outreach, including on, I know, asteroids that might impact Earth. That's one of their major things, is looking for potential impactors.
Was there a deeper connection there other than just like, this is something we want people to know about, or was the Planetary Society involved in the game in some way?
I don't know if the Planetary Society was involved. They might have been consulted for it. I couldn't find any evidence that they were involved in the creation of the game. There is one other very important game component, though, that's not in the box, and that's the app. So if you remember from our discussion from Turing Machine 2 episodes back, the whole thing is like, who has the information you're trying to get out? And that game trying to solve it by saying, okay, the game has the information, and we have these fiddly little boards with holes. That is how you get that information out of the game. The search for Planet X has the same idea. Is like the players don't have information, the game does, but they just use an app to tell you where things are. Now, if you don't want to do that, there is actually a free download on their website where you can download a Game Master kit where you can have one of your friends play the role of the app, and essentially you ask them questions, they give you answers, and you just really hope that they're right and they don't mess up, because if they do, they're going to mess up your game. So I'd probably stick with the app, just because I trust the computer to not make a mistake. So that's basically the game. As you go around, you spend your turn making observations, doing research. Different actions have different time costs, so you can actually take different number of turns over the course of the game. One kind of nice little aspect of the game I liked is that there's a little turn tracker thing that goes around the board that tells you which half of the sky is visible right now. Because the idea is that you're all astronomers making observations. You can only look at the side of the sky that is dark. The side that has the sun, you can't see anything. And so you can only make observations in the half of the sky that's currently dark. And as you move around, that position changes. And so it kind of limits what you're able to look. You can't just look at any sector anytime. You have to think ahead of like, oh, if I do this, suddenly these sectors will go away next turn. I can't do that. There were definitely times when Brian and I were playing that I made some choices based off of which sectors would appear or disappear based off of what decisions I made on my turn.
And there were times that I made decisions that I ended up immediately regretting, because it's like, oh, well, now I can't get that piece of information. So we talk about when we play games sometimes like Earth, where it's very fiddly. There's lots of little pieces to manage, lots of little cubes and cards and dice and everything else that you have to do. Search for Planet X is anti-fiddly. This is the cleanest board game setup I've ever seen. It's a disc in the middle. It's your little meeples. It's just, I mean, and a lot of it's because you have to, you're handing your phone back and forth so that people can use the app in turn. But this game definitely leaves you with room for a bowl of chips.
Yeah, that's the thing. We have definitely had games where there is no chip room on the table afterwards. This one's fine.
Oh, no.
Possibly that simplicity is why they could splurge so much on the scorecards, is because there weren't a bunch of meeples and cubes and other things. So they could just make a really nice printed scorecard.
They had to develop an app that must have cost something.
True. That probably cost a decent amount.
Okay.
And yeah, you don't have to hand the phone around. If you all have the app, then you can just type in the random game code and it will give you the same game each time. But again, make sure you type in the right code or else you're playing different games and it won't work.
Yeah, we actually did have to hand the phone around because I was using my phone to record us playing, so we couldn't do that.
So that's the idea of the game. It's actually, as Brian said, it's a fairly elegant game. I thought it was actually really fun playing. It's nice and simple. Like just trying to find this thing. And there's one other part I forgot to mention is as you go around the board and as the Earth is moving around, it triggers different things. It triggers what's called a theory phase, where essentially you put out a publication saying, I think this item is in this sector. And it takes a few turns for that to work its way in and be revealed. And it's one of those interesting things where you get points for being right. You're penalized for being wrong. So you want to put it out and you want to be right. But no matter what it is, you're giving information to your opponents. Because if you're right, they suddenly know what's in that sector. If you're wrong, they know what's not in that sector. And so there's this little tension of, do I want the points or do I want to keep that information to myself, but possibly be scooped by one of my opponents? And then there is also actually a Planet X conference event that happens when you reach a certain point. Which there's nothing fancy about it. You just learn a new logic rule about where Planet X is located. Like it's not opposite an asteroid, or it's within 3 sectors of a comet or something like that. It's called a conference. You don't actually confer as a group, but it's a fun little thing that they put that in to kind of keep up the appearance of you're actually scientists doing scientific things like putting forth theories and publications and going to conferences.
Yeah, there was a keynote address and everybody's like looking at their own data now. It's like, oh, wait. How does this inform my logical deductions about which sector is actually empty?
Yeah, I really appreciate. I mean, there's a lot of mechanics that we can talk about, but I really appreciated some of those like additional features that sort of give you. There's like, oh, there's a community knowledge aspect, and then there's you have to publish your results to get the points for them. It's so true to the scientific endeavor.
It is, and that's the thing. Like if you go into actual scientific fact, there's almost none in this game. I mean, there are logic rules of which things have to be next to each other. Maybe we can talk on that later. There's not that much science, and yet it feels like science, which is an interesting thing.
Yeah.
And so now we're going to pivot to talking about that science, and maybe not so much the science in the game as the science that the game is representing. And so, Addie, I have a very crucial, critical question for you to start us off. What is Planet X, and why haven't we found it yet?
Yeah, it's a trick question. So Planet X is, I guess I would say the most recent incarnation is sort of this hypothetical planet, right? And even in the game, right? It's in a blank sector of space and you're hypothesizing that it's there. And so I said the most recent incarnation because there actually was, I think when, oh man, I'm totally blanking on his name right now. When Lowell was looking for something that was like Neptune.
Percival Lowell?
Percival Lowell, yeah, sorry, was first looking for another planet that would sort of explain the irregularities in Uranus and Neptune's orbits. They called sort of a companion planet, Planet X. So they ended up finding Pluto, which actually didn't explain the irregularities that they were looking for because it needed to be something with a higher mass. So that's sort of, I think, where the name potentially comes from. And so in the most recent incarnation, there's sort of this hypothetical Planet X or Planet 9, or I don't know, we've called it Egotron a few times on our podcast. There's other fun names that you can come up with for it.
Why is it Egotron?
I don't even entirely remember the full etymology of that name, but it has to do with the fact that like sometimes when people are saying these things about discovering planets, it has to do with egos. But I think that there's additional etymology to it that I would like go back in the catalog and remember why we called it that.
Okay.
I assumed it had something to do with Unicron from Transformers, but
Egotron.
It doesn't. You have to, I think if for our podcast, you probably have to assume some sort of Star Trek reference, but I actually don't think there is one for this. So Planet X or Planet 9 is a hypothesized additional planet that is sort of Neptune-sized, that is far, far out beyond Pluto's orbit. So this is a planet that would be in the outer solar system, and it would have to be like really far out. We think that it's there potentially based on a number of lines of evidence. And this is one of the fun things about the existence or non-existence of it is there's different hypotheses, and the community trades papers about whether or not it exists. Based on new observations all the time. And so the original observations are based on some dynamical observations of smaller bodies in the solar system. So there's a couple of astronomers, including Mike Brown, the Pluto killer, who have had some observations of a bunch of other small bodies that are further out in the solar system that sort of have these interesting groupings dynamically. So like if you look in space, if you're just looking out, they sort of, okay, they're distributed, but if you plot them in interesting ways, they sort of group together. And so that could potentially be due to the existence of another large Neptune-ish sized body that influences the gravity and gravitational perturbations of those planets. And so that's some of the original observations. And I think that was in like 2019 that sort of inspired this. There's some other folks who have said like, well, those orbits that they're on could happen due to these other reasons also. And there's also other things that would happen if you had something that large out there. So where's the observations for that? And then there's been some more recent observations. It's like, nope, it probably is there because this other line of evidence. So there's been really interesting sort of trading of why we think it might be out there. If it's out there, it's really far out, so it's hard to see. But if it's as large as Neptune, there should be some observational evidence of it. So, but we haven't directly ever observed it.
That was going to be my next question, actually, is when we're looking for this or for other bodies out there, how do we go about looking for them? Like, what do we use to try to spy new bodies? I know the Hubble Space Telescope, I imagine it's not used for planet hunting, but what do we use?
Yeah, so when we're looking for planets in our own solar system or planets in other solar systems or other planetary systems, we often use indirect observation techniques. So we look at the wobble of a star, for instance, when we're finding extrasolar planets, where we see that like we're looking at a star, very bright object. You can see it from really far away, right? So we can observe it from here on Earth, from the ground with our little ground-based telescopes in the game even. And we say we can see something that's out there. We can see this star, but its orbit actually maybe wobbles. So that has to do with like gravitational tugs. So like Jupiter actually tugs our sun and it sort of wobbles if we were observing it from outside the solar system. So other large planets do that to their stars also. And we've detected a lot of extrasolar planets from that wobble. You can also do transit techniques where a planet will go in front of a star and then the light blinks, right? And so that's what Kepler is really well known for, the Kepler Space Telescope. And so there's several of those sort of indirect techniques for planets in our solar system and for asteroids and comets in our solar system. Sometimes we do have direct observations. So we see them by either staring a long time into one part of the sky, which I think is one of the techniques you can use in the game.
Yep.
Sort of like, look, do a deep search in that part of the sky, right? And then you see, like, does something come across my telescope in that time, right? Or you can sort of be scanning all the time. So we have some telescopes on Earth that are like Pan-STARRS as one example. It's located in Hawaii that just does like sort of observations of large portions of the sky night after night after night. And then you look for changes over night after night to see if we discover new objects.
Like planets are hard to see, right? I mean, I remember when New Horizons went out to Pluto, it's like the best picture we had with Hubble of Pluto was terrible.
So most of the sort of canonical planets, right, the traditional 8 planets, are observable from ground-based telescopes and even like binoculars mostly, right? Mercury is very difficult because it's very tiny and very close to the sun, but you can see them as points of light in the sky. Pluto, very, very challenging to see even with ground-based telescopes. So the best one we had for a long time was from the Hubble Space Telescope, and even it was not very resolved. So it just sort of looked like a fuzzy blob. It wasn't until we got better imaging from that, and then, like you said, New Horizons got out there, and we were like, oh wait, this is a full geologically active planetary body. So they are, especially when they're as far out as Neptune or Pluto, they're very hard to observe just because it's dim out there. Planets don't emit their own light, so the only way we detect them is from these gravitational techniques or from reflected light, right? And the sun is very dim the further out you get. And so it takes a lot of staring at an object for a long time to collect enough light that's been reflected back from it.
Okay, and so is it mostly visible light, or can we also use, I don't know, radio, infrared, or other stuff to try to see these things?
Sure, yeah. Most of what we think about when we think about looking at these objects is visible light. And a lot of our ground-based telescopes are in the visible part of the spectrum because that's what gets through our atmosphere. You get a lot of really interesting information about other planets from infrared. So that tells you about the heat that's being emitted and different cloud layers on Jupiter, for instance. We learn about that in the infrared, but that's hard to do from the ground because our atmosphere blocks a lot of that infrared light from coming into ground-based telescopes. So you have to do space-based telescopes for those observations. And then like UV light also, yeah, there's a lot of really interesting information that comes from the UV, but we have to, again, thanks ozone layer, actually, right? We like that for our skin cells and everything, but and our DNA, but not so much for observing. So like those kinds of telescopes we typically have to put in space. There's really interesting data that can come from radio, a lot of asteroids, for instance, and things we used to detect with their Arecibo observatory. So that was bouncing radio waves off of things, and you can use that to detect objects as well.
I'm picturing some kind of malevolent AI astronomer bot who wants to eliminate the ozone layer and the atmosphere so that it
Yeah,
can get a cleaner view of space.
that's right. Astronomers are always like, atmosphere. I was shaking my fist for the listeners.
I was actually wondering about that because with visible light, one thing I've heard just kind of scrolling through science news is that a lot of astronomers are concerned with the number of satellites we're sending up, especially these giant arrays of like Starlink, where they're like tens of thousands of satellites that are all reflecting light down to us and they're making these streaks across the telescopes. How is that affecting observations and stuff? And how can we get around it? Because I don't think they're going to take it down internet access, global internet access
Yeah,
anytime soon. So what is the
right.
astronomy field doing to adjust?
Yeah, it's challenging. So that's one of those things that like, yeah, what is the greater good and all sorts of arguments you can make there. Astronomers are always getting mad about things getting in our light. Just turn off all the lights all the time too, by the way. So it's challenging. It does show up in a lot like so Starlink and other constellations, right? That there's more and more of them do show up in observations and do create streaks across images. The worst time is if you're observing sort of around sunrise and sunset because the satellites sort of glint the most during those observation conditions. So like if you're not observing then, statistically you have fewer of these streaks. If you are, they show up. There should in theory be ways to remove them pretty easily from the data. Like they're pretty obvious and there's usually several sets of them that go through an image. But if they happen to go right in front of the object you're trying to view, bad news, right? And as there become more and more and more of them, it makes it more challenging to do the observations that you intend.
And we're getting like SpaceX photobombed.
Yeah, there's a lot of photobombing. Yeah.
I almost wonder, that sounds like the sort of thing that AI would actually be a good use for, is that as you're recording the data, instead of just putting it all in a single image, like you stream it through and it's like, oh, that's a satellite going through. I'm just going to like remove that part of it. And so it doesn't get saved in the final image or whatever.
Yeah, and I mean, astronomers have had to do a lot of image processing and removal of streaks and things like that for a long time, right? So that kind of stuff is like, especially because they're going to be linear features, they're pretty easy to like detect. So even without AI, there are techniques to remove those types of things. I think it's something that you have to have adaptive versions of your analysis pipelines to be able to handle some of this stuff. I think that's going to be the solution, right? I don't think, yeah, like you said, I don't think we're not going to have these satellite constellations. So, or more space-based telescopes, but those are way more expensive and so.
So I then want to zoom back a little bit, even from this specifically, but talking about planetary science. People have been staring at the planets for thousands of years. We've been using telescopes on them for hundreds of years. What's it for? What are we pulling out of planetary science that is worth pouring all this time and energy and papers and conferences and all sorts of stuff to try to find stuff on these planets?
What is it for? That's a great question. So planetary science is for a lot of us and for a lot of people is about understanding the Earth's place in the universe. So planetary scientists are typically studying other planets in order to understand things about those other planets, but also to understand the basics of how those planets formed and how the solar system formed and how the Earth came to be and why all of these things are like they are right now, to understand like how the Earth came to be and how life came to be. A lot of it is just sort of a really innate curiosity, I think, about the universe, right? That drives us to be astronomers and planetary scientists, the same as a lot of scientists are just sort of innately curious about the things around them. And so I think that like how that's expressed then becomes like this thing that is studying planetary bodies or planetary bodies in our solar system or in extrasolar systems. And yeah, I think a lot of it comes down to like, why are we here now in this place in the universe? And how did we come to be here? And what is that? And how might we evolve, right? Because we can learn a lot about the evolution of planets and the evolution of stars and planetary systems by looking at our own and then at others.
Yeah, actually, I was on a road trip with my daughter this past week, and due to some podcasts we were listening to, we ended up talking about the Drake equation,
Oh,
which
sure.
is is basically our place in the universe and how special are we? Like, what's the odds that we would contact another alien race essentially that is at a similar technological level? And it has all these factors of like, okay, the number of stars in the universe, the number of stars that are kind of like our sun that could host life, the ones that have planets, the ones that have planets in the right spot, and so on and so forth, like all these different terms. And so far, no one knows the answer to most of those. So it seems like,
Yeah.
while the purpose of it is not to fill out that, I don't think the Drake equation motivates many people. It seems like it's that same idea of like figuring out where we fit, for lack of a better word, how special are we, and trying to keep that in perspective, which I feel like the thread of science for the past 500 years has basically been keeping us humble and pointing out that we are less and less and less the center of the universe that we thought we were.
Right. We're definitely trending that direction. Yeah. Yeah. I mean, it's funny because, the Drake equation is always a fun one to think about. And like, so Frank Drake came up with it in like the 60s, I think. And it was this sort of, it's a statistical probabilistic argument about what the number of civilizations might be. Right. And there's occasionally people propose a new term to add to the equation. But like when he proposed it, we had almost no information about any of the variables that he included in the equation. And so like, it could be one, right? It's an N where N could be one. It could just be us. But it has to do with like the number of stars in the galaxy. And so every time we discover new things, the statistics about how many planets there are out there and how many planets there are around stars, right? Like all of that's happened in the last 2 decades. And that's really given us a lot more knowledge about how to sort of fill out that equation. But there's always this question of like, how many of those actually have life? And how long does life and civilization last on a planet? And then also like, if it exists on a planet, how does it move away from that planet? And like, that's another thing that's the aspect of my interest is in exploration, right? So if we understand what it's like on the moon or on Mars and how do we go there as a civilization also and sort of expand our presence in space, I think that's an ongoing driving theme as well.
Yeah, we've actually done 2 previous games on space exploration and colonization, Terraforming Mars and Stellar Horizons.
I love Terraforming Mars.
Do you love Stellar
That's
Horizons?
so I've never played that one.
Okay, well, set aside a weekend because the full campaign takes how long to play? Full 8
like
hours?
8 hours.
8 hours.
Oh man, it's longer than Mars.
Oh yeah,
Wow.
no, absolutely. Because in Stellar Horizons, each turn is a year, and you play through 200 years or so. You only get your funding every 10.
Wow.
You get your funding every decade, which certainly feels very real right now.
Yeah, I was going to say too soon.
So if any of you listeners haven't listened to that, you can go ahead back and listen to that. We have a NASA engineer on talking about that. But for now, we're sticking with searching for Planet X. And
Yes.
Addie, when I asked you about planetary science and getting information, I was kind of implicitly talking about the planets in our solar system, but you mentioned studying extrasolar planets. What information can we get from them? Like what data can we get about something that, as I understand it, is not even a pinprick of light in our telescopes? What can we get from it when we try to find them, when we look at them?
Yeah, increasingly when we talk about planetary science, we do talk about extrasolar planets, right? And planets around other stars. And part of that is those of us who study rocky planetary bodies or bodies in the inner solar system, typically, like those are very specific ones that are close to the sun and like the Earth and Mars and Venus, right? But then when we talk about those, we also include things like moons of outer planets now sometimes in those discussions. Like, so I mentioned earlier, Titan is this really crazy moon around Saturn that has a really thick atmosphere and it has like weather processes similar to the Earth, but like the rocks are basically ices instead of rock material, right? So it's really interesting to think about like what other sort of potentially places we could go or where life could exist or where we could go and have habitats might exist in our solar system. And so I'm coming back to your question, which is like when we're studying other planetary systems that are very far away, right? They're around other stars, they're very far away. We get a lot of secondary information. So I was talking about earlier, the different ways we detect them is by indirect methods for wobble or transit. But we are increasingly being able to get more direct methods. So if you have the transit method and there's like an atmosphere of the planet, as the planet goes in front of the star, some of the light from the star goes through the atmosphere, and then you can actually measure spectroscopically some of the constituents of the atmosphere. So you can actually get information about the atmospheres. You can get better information about the sizes of those planets planets. And so these things all tell us about like how many planets are there around other stars and what's the chemistry of those planets and do they have atmospheres or are they rocky? And so all of that can tell us again about like how unique the evolution of our solar system has been. And like 15 years ago, when I was in undergrad, right? We actually didn't have a lot of extrasolar planets we detected yet. And even like 15 years ago, when we'd just been starting to detect them, we're like, okay, these are all weird sort of configurations we're discovering. Like we're discovering Jupiter-sized planets that are close in and Jupiter-sized planets that are like at the location of Earth, right? And like those are all super weird, but it's because that's the type of thing we can detect. Like it's easier to detect those things. That's not like representative. But as it turns out, as we've discovered thousands and thousands of extrasolar systems, the like configurations of those planetary systems is statistically not like our configuration in our solar system. So all of our like ideas we've had for, I don't know, 60 years about how our solar system is shaped and evolved have had to be restructured in light of these other observations to think like, why is our solar system configuration so unique? And how has it maybe changed throughout the evolution of the solar system to be the configuration we see today? And how would that have affected nascent life on early planetary bodies and how they evolve?
That's interesting to think about because, again, there's this trending of assuming that we are very typical, we are very average, we are very bland, because that has been the pattern of science as we have gone, is that there is nothing particularly special about us. But as we're learning more about solar systems, that's not exactly true. Our solar system is a little weird, or at least a little atypical.
Yeah, it is. It's super atypical. And like we still have some observational biases. Like it's still really hard to find like an Earth around another star because it's small. So like you're not going to be able to directly detect it. But also it's small, so it's not going to cause its star to wobble very much, right? So there's a lot of biases against detecting those things. But we're still seeing like way more planets close in, like large planets close in than these large planets close out. And we have enough data now to be able to detecting more of those. So it's really interesting. And I think, yeah, there's like the cosmological principle. And I think we apply that in other things too, is like when we're making these assumptions, you have to assume that like you're not observing a special place or a special time because that it makes it hard to like make broader assumptions about the thing and extend those observations. But it does turn out that like some parts of where we are in the solar system are special and some parts about the evolution of our solar system are special. And like how does that apply to then one of the variables in the Drake equation, right? How does that apply to us understanding like how unique we are and how unique the evolution of life is?
Hey, and you talked about the evolution of our solar system. You can maybe answer something. I have heard that according to recent models, the idea is that originally Jupiter and Saturn were in the opposite order. Is that true?
What?
Yes. And like Uranus and Neptune were in totally different places too. Yeah. So there's these fun sets of models called the Nice model, but it's Nice, France. So it looks like the nice model. And it's a very nice model. There's nothing against it, right? Yeah, those jokes are probably a decade old now. So
Not to us.
so that model, yay. So that model has, and then there's a newer one called the Grand Tack. But anyway, they're dynamical models of like the evolution of the solar system. And the current configuration of the solar system is pretty stable. Like things aren't moving around very much, but probably way back in the past, things were in different orders and like Uranus and Neptune were closer in and Saturn and Jupiter could have been switched. And then due to gravitational interactions, they like sort of tug at each other and they would have like caused one to sort of move in and one to move out. And then this also scattered a lot of asteroids out to further out in the solar system. Yeah, it's pretty crazy.
Oh man, all my mnemonics are going to have to change based on the model. You can't be my very energetic mother and then everything else is out of order.
I know.
Oh,
I
geez.
know. And then the whole system's out of order.
I'm pretty sure your mnemonics have been valid for at least the past 2 billion years. So
All
I think
right.
we're good.
Okay. All right.
Yes,
Fair enough.
it's been a long time. And actually, part of this ties to like the cratering we see on the moon and when that happened. And so there's some interesting, very close in ties to this evidence for that.
And I've got a question on some of the logic rules here in the game because they have rules
Yes.
about what shows up where. And I don't know if any of these are somehow reflecting reality. Like comets can only show up in prime numbered sectors, but I think just means they can only show up some places, but not others.
Yeah.
Or a gas cloud has to be next to empty space, or asteroids always appear in clumps. Do these reflect the way the solar system is actually laid out?
Yeah, first of all, I don't know why there are gas clouds. What is that? I don't know why there are gas clouds in our solar system. That one seemed a little strange to me. There's so many types of objects you could have picked, but
What should they have picked? What should they have picked? We're almost doing our nitpick corner. What would have been better than gas clouds?
oh, I don't, I guess I don't fully understand what they're supposed to represent. So I don't know.
I hear about clouds of gas being things that exist out in the world, but not in a solar system. Usually all the gas should be in planets and stuff, right?
Yeah, there's gas on, like, there's clouds on planets and there's gas in planets. And then there are like gas clouds and molecular clouds and things like that out in the broader galaxy.
You're like dust
But yeah,
clouds?
we don't have like gas clouds per se. There are dust clouds. We
Okay.
could call it dust clouds,
Okay.
maybe.
Okay.
So asteroids, I think I understand. So asteroids, there's like the asteroid belt, right? Which is in between Mars and Jupiter. And there's like sort of other groupings of asteroid-like objects that tend to be sort of dynamically grouped together. So in the same sort of place in the solar system. And that has to do with like probably how they were formed and how they broke up from an object and then sort of stayed together. So like I can kind of see that rule. I think that's supposed to represent maybe like the asteroid belt or like asteroid families, because we do have families of asteroids that we call them.
Hmm.
For the comets come from further out in the solar system typically, and they have long orbits, and there's different sort of types of things. So maybe that represents that they can only, yeah, I don't know, that we only see them periodically, right? So like maybe something like that. You can think of like Halley's Comet as the one we think of that comes by every 86 years or whatever, right? Because they go really far out in the solar system and they come close in. Maybe it has something to do with that. They're only in prime numbered spots. There's fewer of them.
It's interesting that we actually didn't even, and I mean, not that you would have to know this, but when we played this other deduction game, they wouldn't use something like, oh, it must be in a prime number because they weren't assuming that people knew what that is, right?
Oh, wow.
Well, this one is easy. On the scorecard, they don't print a comet unless it can actually show up there. So
Mhm.
I guess they could control that.
Yeah, it's all like design. They're
Yeah.
not assuming people. We did have a discussion about whether or not two is a prime number. You remember having.
Oh,
2 is a prime number.
Okay.
it is.
And the last one is that a dwarf planet can't be next to planet X. And that's part of what you have to use to figure out where planet X is in the game.
Mm-hmm.
Does
Mhm.
that reflect like this grouping of planets that you say some people are using to say where planet X is? Like, would it have like gobbled it up or like cleared its orbit or?
Yeah. Is if we
Oh,
find
there's
a
that term, right?
yeah, for sure. If we find a Neptune-like object, is it going to be a
Mhm.
planet or not?
If we find a Neptune-sized object far out in the solar system, it would most likely be a planet.
Okay.
Yes, by the current definition. I'm using air quotes
Yes.
for definition, even because it's a terrible definition. I'm fine with Pluto not being a planet, but I still hate the definition. Anyway, that's
Okay.
my take on that. So I think that would make sense. So part of what the deal is with Planet X is that it's like there are some gaps in where we don't see some of these small objects further out in the solar system. And there are certain like arrangements of some of the dwarf planets we have discovered. And so part of the hypothesis for Planet X is the reason there you see those things the way they are is because of the gravity of this larger planet is sort of pushing them into those locations. So I'm okay with that rule.
Can we talk about the dwarf planet definition and how you don't like it, or do you not want to talk about it anymore?
No, I'm happy to talk about
Because
it.
our
Yeah.
last episode we had a bunch of controversy too. So evidently this is the controversial
Oh.
season of gaming with science.
I love it. Yeah, so the IAU definition of like what is a planet, right, has these like different things. So it has to be spherical, so it has to be like large enough to sort of make its shape spherical, and that has to do with like basically how big it is. And then there's this other sort of much more controversial rule about it has to have cleared its orbit. And so that's like sort of a dynamical argument of like where it's going in space, and there aren't a lot of other things right in the same orbit. It doesn't make any sense. It's a dumb rule because like Neptune and Pluto's orbits cross, and there's lots of these other like types of objects in both of those orbits, and there's lots of other objects in Jupiter's orbit. There's other things in our orbit. So like it's just not a great definition. There probably should be some sort of like geological definition potentially of a planet,
Okay.
or there's lots of other ways you could go. And there's other definitions that have been proposed, but I think the idea of having like sort of canonical planets and then dwarf planets and sort of having some size differentiators is fine. We have different types of bodies of water, right, on the Earth, and there are different classifications for like rivers and streams and things like that, right? So like there could be sort of these different definitions, and I think that's fine. And you have Pluto and the Plutinos, which is also a great band name. So there can be a little bit more nuance or like uncertainty in nomenclature, I think.
So last thing I want to cover about the game here is the aspect of the doing science it covers. So like you put forth the theories, and Brian had determined that the fact that you put down a theory, but then it takes like 2 or 3 turns for it to work its way towards the center and you actually see what it is. That's peer review.
That's peer review.
It's like the
It's
peer
too
reviewers are
true.
looking
It's
over
too
it, the
true.
reviewers are doing it. And the
Reviewer
fun
number
thing,
2.
Yeah.
yes. Yeah. See our previous episode on Publish or Perish.
Mhm.
So,
Yeah.
but the interesting thing is that just like real science, it rewards you for being first. So if you're the first person to publish that and get it right, you get a bonus point at the end of the game. If your paper is essentially in peer review at that time, you still get points. But after it's revealed, you don't get any points for saying it again, because like that's already known. No one cares about you, like you saying, I have rediscovered Mars. It's like that doesn't do anything.
Although people rediscover water on Mars all the time.
Yeah,
So
that's true. You get to put it in your annual performance review.
there you go. Yes.
Although I
important.
complain about this, and I did complain about it when we talked about Publish or Perish, and I complain about it in general. Science is supposed to be repeatable. If somebody discovers the same thing using a different line of evidence, that's a good thing. That means that the
Yes.
system is working.
Yeah.
So, but you're
Yeah,
right.
yeah.
There is this priority. It's like they don't get to be the one to name it. That's just the fact that it's a human jobness being on top of the scientific endeavor, right?
Maybe. But my question is, like, in the planetary science field, like, what are the current arguments that are going back and forth in the literature where people are pushing one way or another that things haven't been settled? You mentioned that the existence of Planet X is one of them, where people argue for or against it based on certain evidence. What other stuff is out there right now that's being debated?
Ooh, fun question. So many things. It's funny, like we have all of this information, but like every time we have new planetary missions, right, it opens up new questions and opens up new debates about things. One of the big ones that's been, I actually haven't seen an update on this in a little while, but that's been going around the last few years is this question of like sort of life producing products in Venus, on Venus and in Venus's atmosphere. That was a popular one for a while. So there was this paper that was published that there was phosphine, which is a specific type of molecule in Venus's
I
atmosphere.
remember that.
And the big thing about that, right, was that it's probably produced by biological compounds. Like it has to be a biologic origin.
In
So there
Venus?
had to be something biologic producing it. Yes. So this was the paper. But there's been all these other things since then of like, oh, well, there's all these abiotic ways to make it. Or maybe that's not a detection of that line that you think it is. It's like because it was a spectroscopy. So it was a specific line and an observation. And so like maybe you're looking at actually a different line. It was a different molecule, right? So there's been a lot of fun back and forth about that. And like if there's life on Venus recently, that's been a fun one. There's a lot of hypotheses so I study the moon a lot these days. There's a lot of different hypotheses for like how different things formed in different places on the moon and what that tells us about like the history of the moon's evolution and also the Earth's evolution. And so those are always really interesting. I think like, yeah, this big question about like, are there other large planets further out in the solar system is going to be one we keep having. And then also like on sort of the astronomical scale, there's all these questions of like, what is dark matter and what is dark energy and what do those things tell us about the evolution of the universe? Big questions that have a lot of like different hypotheses that sort of bubble up to the surface every now and then and get pushed back down, and then another one bubbles up.
All right, well, we need to start wrapping it up. So, Brian, you like doing the nitpick corner. So, do you have any nitpicks about this? There's not that much science in this to pick.
I do have a nitpick, and it is as you are proposing your theory and it advances through the peer review process, and then it gets flipped over, it's always correct. It's just, as it goes through peer review, it is now the truth, and it will reflect the truth, and that's all that there is to it. So that's my science nitpick.
Well, I guess, yeah, in reality, we don't have an omniscient app that we can just ask if we got it right. That would actually make our jobs a lot easier.
Yeah, it would be great if we just had an app that had all the answers. My gaming nitpick is not even a gaming nitpick. It's just the truth of any kind of logical deduction game. The first time you make a mistake, you're screwed.
Oh
If
yeah,
you
you crossed something off in the wrong region,
I did
didn't
something
you?
in the wrong place in the wrong time. And it's like, technically, if you're really careful and if you're really diligent about how you've coded all your information, you could go back and figure it back out again. In single player mode, sure. But if you're actually playing with other people, you don't have time to go back and be like re-logicking all of your logic. So that's just, again, another example of me being bad at games. So
The scorecard actually has space for you to record all your own moves and all your opponent's moves if somehow you have the brain space to be able to think what they're trying to
I know.
deduce too.
mhm.
I don't know how
Yeah.
people can do that, but congratulations to you if you can.
Well, it's nice to kind of have a place to write it down, actually, because a lot of times you're sort of trying to keep track of those things in your head. So it is kind of nice to have a place to write it down.
For sure.
I don't have nitpicks. There's not much science to pick at in this game, and I actually really enjoyed it. I thought it was quite well put together.
I guess we already know Addie's. There's no gas clouds in the solar system.
My nit was the gas clouds.
Okay. From here on out, whenever we play, they are dust clouds. We
Yeah.
can find dust clouds out in the solar system.
Yes.
Or hey, what
Perfect.
else should it be? I mean, if there's something else it should be, we're just going to print up new cards and it'll just be
Well, I don't know. I'll think about it. I
Egatron
don't know.
radiation.
Yeah. Oh, you could have like solar wind plasma or something,
Okay,
maybe.
that sounds cool. I think that one of the things is that that's probably for, people like myself, I wouldn't really know the difference between solar wind plasma and a gas cloud. I would assume that they were the same thing.
Aren't they the same thing?
Oh no.
No? Oh. That's what happens when you ask a biologist space questions.
Well, every time you're saying evolution, I'm having to recalibrate my brain. It's like, okay, not that kind of
Oh
evolution.
yeah.
It's a different type of
Yeah.
evolution. But no,
Yeah,
I mean,
different type.
I kind of appreciate that the challenge is they were trying to use stuff in the solar system that is hard to see, hard to observe,
Hmm.
right? So, but that people would
Yeah,
also know.
true.
So I think that's why we ended up with gas clouds.
Probably. Yeah.
But they're cool with people knowing what prime numbers are, but they're not going to say plasma.
Right.
Yeah.
Or different types of radiation.
All right. Well, then let's go on to grading. So we're all university professors here. Addie, you can participate or not if you want, but we like giving a letter grade for just how well did it do for the fun and how well for the science. But let's start with science, since that's what you were just talking about. Brian, standing on your plasma clouds and peer review and everything, what would you give this for the science?
Let me think. So my biggest concern is, are you going to come away with something fundamentally wrong from the way that the science is being depicted in this game? I don't think you will. I think this one sort of, again, leads a little bit more towards the process and a little bit less towards the, okay, asteroids are not going to be necessarily be found right next to each other. I don't have a problem with a B. Does anybody think I'm being too harsh? Am I going to get a request for a regrade if I give this a B? Should this be a B plus?
I was going to put forth a B
Oh.
plus.
Okay.
Similar things in that it's not trying to convey a bunch of science fact, but there's all those little things it didn't have to do, like the papers and the peer review and the conferences and stuff. Those help make it feel like science. And so I want to bump it up a little bit for that.
Modeling the little
Yeah.
meeples after actual telescopes, making
It's pretty
sure that
adorable.
the night sky had to move and that you couldn't observe everything at the same time, which makes it very tactical,
Yeah.
but also brings in this, not realism, but because you can't do realism, but a fun metaphor for what you're actually trying to do.
Yeah, I think even like the turn mechanics, right, where it took different amounts of time to do different types of observations and like that would give you different amounts of information. I think that added like an interesting realism to like how long it takes to do science.
Oh, yeah. And how you have to declare what you're doing to everyone because,
You got to book that telescope time.
yeah, everyone
Yeah.
knows you're booking the telescope time. I was actually just looking at the board to see if there were any actual constellations on the background. I couldn't spot any, so I think it's just an artistic star background, but that would have been cool if they put a few of those in too. All right, what about gameplay? So I guess I'll go first. Addie, you didn't have a chance to play this, right? You were able to watch some actual plays and stuff.
Yeah, it looks fun. I would like to play it. I'm going to try to if I can find it around here somewhere.
I'm sorry we didn't get to play. I was in Florida, but our schedules just did not align.
Yeah, that would have been fun.
Appropriate enough, it's only when the planets align that we're actually able to play a game with someone. So, sorry, couldn't pass that up.
Addie, are you cool with the B plus? Because I had one of my somebody listened to the podcast. I got a comment that said that we didn't let the guest give a grade last time we had a guest
Oh.
on, and not on purpose, but I think the conversation just moved away from it.
I think I'm okay with a B plus.
Okay.
I also don't have like the grading scale, right? So I'm fine with that being a B plus.
Okay,
Yeah.
we definitely do grade inflation. We start at a B. And you could do better or worse than that.
Okay. Okay.
All right, so fun. I'll take the lead on this. And I thought this was really fun. I actually really enjoyed playing it. I think the little fun science touches were good. I think the play balance of like, oh, I'm using this many turns and trying to find things, it just felt fun. And this is weird because last time when we talked about Turing Machine, we talked about going for the pure mathematical abstraction and not skinning something else on top of it. And this is the complete opposite. This has totally been skinned about science and finding this thing that has nothing to do with the logic rules behind it. And yet I found it really fun.
Mm-hmm.
I actually found it more fun than Turing Machine, I think because it resonated with me of like, oh, I'm hunting for this thing and there's comets and asteroids and stuff, rather than this logic rule about triangles and squares being more than circles or something like that. So I'm going to give it an A. Like, this is a game I would gladly play again. So I definitely give it an A. A minus at the lowest.
Guess, Addie, you didn't get a chance to play, so I guess you're going to abstain.
I haven't.
Okay.
Mine's a pending. I have an incomplete grade.
Okay. All right.
I'll have to update it next semester.
Okay. Oh, Jason, this is hard because I crapped out at the game. Like I screwed it up. So maybe I'm gonna give it a B because I want to give it another try. And I actually do legitimately feel bad because we were very complimentary about what Turing Machine did. It's like, oh, it's just pure deduction. It's just a puzzle. But you're right. It's so much more fun if you get to pretend that you're doing something. The role play is so much more fun to be like, well, I am an astronomer looking for a planet. Now I'm going to publish that information.
I respect the people who did Turing Machine for making that choice. And I think for what they wanted to do, it was the right choice. I enjoy this one more. And I think for this game, it was the right choice. Like they wanted it to be fun. And I mean, it seems to have worked. Like I said, 107 on Board Game Geek. They seem to have cracked the code to get a really high ranking deduction game.
And where is Turing Machine on that ranking? Not that I want to appeal to the masses to see which game is better, but I am curious.
Let me look that up.
Okay.
I think Turing Machine probably has a much smaller distribution, so I don't know that that's necessarily fair.
And Turing Machine also has a very ardent group of supporters.
Okay, Turing Machine is 324.
Okay.
So lower, but actually not that much lower.
Yeah.
Like when you're talking about the tens of thousands of games on Board Game Geek, anywhere in the top 500 to 1,000, I consider good.
Mm-hmm.
So yeah, Turing Machine is also up there.
Okay. Now I'm curious if anyway, this will be extra credit. I'll see if there are any deduction games that are higher on the list that we haven't looked at yet.
Yeah, they probably have nothing to do with science, unfortunately.
Yeah, so we can't talk about them.
Nope, verboten, at least on this podcast.
Until we have that gaming without science bonus episode that we've been talking about.
All right, well, I think we're going to wrap it up there. Addie, if people want to look you up, where can they find you?
You can find me on Walkabout the Galaxy or wherever you get your podcasts or walkaboutthegalaxy.com. You can also find me at the University of Central Florida. And let's see, I'm on Instagram as Astro Addie. And I also have a mascot that has an Instagram. His name is Citronaut_Dave, CITRONAUT_Dave. And he goes to space and does fun space things. So he's fun to follow too.
Like for reallys? Like he really goes to space? Oh, she's going to fetch something. Aww.
Dave.
We're looking at a cute little stuffed green-faced person.
Yes.
I'll see if I can find a picture that I can link in the show notes, but otherwise look up Astro Addie on Instagram and hopefully she has the link to
Citronaut Dave. Yes.
Citron Dave. And I have to ask, so your Instagram is it basically consists of cool pictures of planets and stuff?
No, that's actually my personal Instagram and it consists of not a lot of things because I don't use it very often. Citronaut Dave's Instagram is much better because it consists of my spaceflight projects. Okay.
I was asking because my family's card against humanity, one of the cards is cool pictures of planets and stuff. And I was hoping I could connect you to another game. Oh, well. All right. We should probably wrap this up before it goes completely off the rails.
Where the heck is the stock outro that I wrote? Where is it? I don't know where I left it. Do you know where it is?
It's on my notes here.
You have it?
I'm looking at it.
Okay, good. So, look, we could never end the episode properly, so we actually finally wrote it down. And now I don't know where it is.
Okay, so thank you, Addie, so much for coming on. Hopefully we get to see you at Dragon Con again, if you're going to be there again this year. And with that, we're going to wrap it up. So thank you, everyone, for listening. Have a great month and great games.
And have fun playing dice with the universe. See ya.
This has been the Game with Science podcast, copyright 2025. Listeners are free to reuse this recording for any non-commercial purpose as long as credit is given to Game with Science. This podcast is produced with support from the University of Georgia. All opinions are those of the hosts and do not imply endorsement by the sponsors. If you wish to purchase any of the games we talked about, we encourage you to do so through your friendly local game store. Thank you and have fun playing dice with the universe.